All right, for number 5, okay, make sure you draw a diagram, make sure you draw a good diagram, right? Use the space. So Joe and Yank are pulling up a tree stump. Okay, I think this is the third or the fourth tree stump we have pulled in this topic, on this topic. Okay, so Joe can pull with a force of 175 pounds. So let's go ahead and draw the dot right here. That's a tree stump. And then let's say this is 175 pounds. And then Yank can pull with a force of 150 pounds if they pull at an angle of 23 degrees with each other. Okay, so 150, a little bit shorter. Okay, and this is 150 pounds. And the angle right here is 23 degrees. Okay, to each other, what will be the magnitude of the resultant vector? Okay, so let me do something wrong first, because I want to make sure that everyone knows what is the wrong thing to do. The wrong thing to do is that people don't look at a diagram and just connect these two arrows head together. That's wrong. That's not the resultant. Okay, now just think about this. If this is the tree, right? The tree is right here. I mean, the tree stump, not the tree, but just think about something, the object right here. And you have two people pulling to the right-ish. Where would the object move? It would make no sense that the object moves to the left at all. Okay, whether it's to the left or to the bottom right, it makes no sense. Okay, so don't do that. Okay, another wrong thing to do is that someone will just do this. This is a very, very wrong thing. And we need to know how to prevent ourselves from doing this wrong thing. This is the very, very wrong thing to do. Okay, and this is wrong because the vectors are not connected from head to tail. So we can't find the resultant, okay, based on this current drawing. This angle is not correct. Okay, so that's not correct. All right. So in order to create a good, accurate drawing, I mean, this is accurate drawing, it's just that we need to fix something. What we need to fix is that we need to move one of the two vectors so that it's connected to, so that they are connected from head to tail. And then you can draw your resultant. And well, we need this angle. We need this angle. And don't forget this is 23 degrees because parallel lines. Okay. Or you can just say this angle and this angle, they would add up to 180 due to the fact that it's a parallelogram. And they are supplementary to each other. So the obtuse angle right there, it's going to be 180 minus 23, which is 157 degrees. So it's actually a cosine of 157 degrees. Okay, that is the angle we need. Okay, so we can now go ahead and compute. We say, oh, by the way, I need to put a square root. I forgot to put a square root right here. Okay, so that square root of everything here will give you the x value. So we have 150 square plus 175 square minus 2 times 150 times 175 times cosine of 157 degrees, right? Yeah, 157 degrees. So close parentheses, and then need to raise to the 1/2 power, which is the square root. So we've got 318.515. 318.515 pounds. That would be the magnitude of the resultant vector. Okay, that would be the magnitude of the resultant vector. Now, another wrong thing to do, okay, which is done by some students, is that some students, they somehow think that this little angle right here, it's half of 23. It's not. It's not half of 23. Okay, this is just not. Okay, because the purple line, it's not an angle bisector. Okay, the purple line, it's not an angle bisector. It does not cut the 23-degree angle into two halves. So those people who wrongfully assume that it's the half of 23 are the ones who tend to use law of sines instead of law of cosine. So yeah, that's the main problem. Okay, so make sure that you draw the right diagram and understanding that when we talk about the resultant vector, the vectors must be connected from head to tail. Okay.